All right, looks like we've got a pretty full room this afternoon. I believe today is Wednesday, and everybody's still awake and here from the party last night, so that's good to see. Today's session is high availability solutions with SharePoint 2013, 2010, so it's fairly agnostic as to the version of SharePoint that you're choosing to run. The session itself is going to provide an overview of some of the available high availability solutions that complement SharePoint products and technologies. And then also what it does is it's going to set the stage for some sessions that are going to follow not only right after this session across the hall, but also tomorrow, where we'll get deeper into high availability and we'll get deeper into disaster recovery. And we'll look at some of the internals that facilitate our options with SharePoint. Sorry, the clicker's not working.
There we go.
So I'm Bill Baer. I'm a senior product manager in our SharePoint product group. I focus on a day-to-day basis on the infrastructure aspects of our product. And with me is...
I'm Rick Taylor, and principal with I Got It Technical Solutions. I used to be his little chew toy when I worked at Microsoft.
So a little bit of background about me. Prior to coming to Microsoft, I was with Hewlett-Packard by way of Compaq and Digital Equipment Corporation, and then prior to that, I was with Apple Computer. You can connect with me a number of different ways. You're welcome to ask me questions outside of this room. You can find me on LinkedIn, you can find me on Twitter, you can find me on Facebook, you can find me on TechNet, or www.wbear.net will take you to all of those places. You will find a Bill Baer on MySpace, and I assure you that is not me.
Yes, it is. It's just that he's wearing a disguise. I call myself kind of an infrastructure plumber. If you kind of think of what a plumber does, if a plumber doesn't do his job right, your house doesn't smell too good. So as far as SharePoint is concerned, I spend a lot of time in making sure that SharePoint is going to do what my customers need it to do, and making sure that the infrastructure hygiene is straight, because if DNS doesn't work, if your DC isn't straight, if any of that other underlying information, such as SQL and high availability, isn't good, then SharePoint is not going to do what you like. So that's my little background.
So today, from an objectives-based perspective, we're going to talk about some of the concepts of high availability, how they apply to SharePoint, some of the features and capabilities that are available to SharePoint, what works well within the Microsoft stack, because believe it or not, a lot of customers are looking at high availability solutions for their SharePoint topologies, but what they don't understand is what they already have as part of the Microsoft stack. So that's one of the first things to try to understand is, what do you have that's available to you to which you don't have to incur additional cost in order to use? And then lastly, what are the base technologies that are going to drive a highly available design? So to kick it off, we're going to first talk about what is high availability in general, some of the infrastructure capabilities that are available to SharePoint, some of the topology aspects of SharePoint. SharePoint is obviously a tiered model. A lot of people don't like to look at it that way to this date, but even though as our product continues to evolve, it still maintains that same conceptual aspect in terms of tiering. You have a web tier. You have a tier that's responsible for responding to HTTP requests as issued by users. You have an application tier, generally, that's responsible for managing services. And then lastly, you have a database tier that's obviously the platform through which SharePoint consumes its services, because we are built on top of the database. And then lastly, there are client capabilities that should not be overlooked. High availability isn't something that you should do in isolation and purely focus on the IT professional aspects of high availability, but you should also look at how users can participate and what's available to them. So to start with an overview, there's basically two layers to availability. There's a data-centric layer, which encompasses failover, backups, so taking full backups, incremental backups, differentials, failing over automatically, failing over manually, the use of database mirroring. In some cases, in asynchronous modes, there's the use of log shipping. There's the use of failover clustering if you're thinking about distributing a cluster across geographics or even across data centers. Those are largely recovery-based solutions. What we're going to talk about today are the application-centric solutions, which is load balancing, active-passive type scenarios, active-active type scenarios. What is high availability in general? It's usually expressed as a percentage of uptime, and that's represented by a number of nines. So if you look at the graph that's on the screen right now, you have a series of uptimes, and those uptimes are related to the annual downtime allowance. And what are those allowances? If you look at 2 nines, you can effectively have 3 hours or 3 days, 15 hours, and 36 minutes of downtime in any given year to achieve 2 nines. Most customers want 5 nines and beyond because the more nines you have, the cooler you are. Unfortunately, SharePoint's not a product that's necessarily going to facilitate 5 nines. If you look at 5 nines, you can afford 5 minutes of downtime in any given year. How many of you can patch SharePoint in 5 minutes? Apply a cumulative update and install a service pack and have it back online in 5 minutes. We're hiring for those individuals that meet that criteria. But 5 nines is a stretch. 6 nines is even more of a stretch because you can only have 30 seconds of downtime. So what do customers do in order to achieve the nines that they think they need?
They lie.
They build in artificial maintenance windows, right? And Rick said that perfectly. They build in artificial maintenance windows. I spent a lot of time with customers where I've sat down and asked them what their availability scenarios look like, and they say, well, we're a 5 nines. We have a 5 9 solution. And I asked them exactly how are they facilitating 5 minutes of downtime in any given year. And they say, well, we have maintenance windows. And I ask them how long their maintenance windows are, and they say 4 hours a week. Right? So, which pretty much puts them to the 2 nines. But like I said in the very beginning, they don't want to say they're 2 nines because it's not as cool. Yeah. They want as many nines as they can. Yeah. Where does SharePoint fall? SharePoint can reliably be done as a 4 9 solution. You can do SharePoint as a 4 9 solution. One of the ways that you should think about it as well is in your head you're thinking, okay, well, you guys do a cumulative update every other month or every other even-numbered month on the second Tuesday. You guys give me a cumulative update, and I install it, and I incur downtime as a result of that cumulative update unless I'm doing high availability patching. And we've got a whole white paper on how that works. But at the same time, too many customers apply every cumulative update as it becomes available, because they feel like the more current they are, the better it's going to run. I always recommend looking at the cumulative update and figuring out, does that cumulative update or service pack address an issue that you're currently experiencing? So it's like going to Windows Update, just clicking every box and installing, and then you hope for the best.
I guarantee you do that, you're going to subtract 1 9 every time you do that.
So some of the terms you may hear Rick and I use today are RTO, which is Recovery Time Objective. That's basically how long is it going to take before SharePoint comes back online. RPO is the amount of data loss that you can potentially incur, expressed in a number of minutes. So you can incur, say, 5 minutes of data loss, 10 minutes of data loss. If you talk to customers, those two numbers, they're going to want 0. 0 downtime, 0 data loss. Then you also have MTBF, which is mean time between failure, and lastly, mean time to repair, are some of the terms we're going to use. Taking all of those things into account, you can build what we call a deterministic calculation model. So availability basically equals mean time between failures divided by mean time between failure plus mean time to resolve or mean time to repair. What you ultimately want to do at the end of the day, absent of all the math in order to come up with the right number, is basically you want to increase the amount of time between failures and decrease the amount of time it actually takes to resolve a failure. So it's pretty easy to figure out. From a planning perspective, and we're going to move through this first section pretty quick, understand that your capabilities is what's going to drive limitations of what you can do from a high availability perspective. You're going to have infrastructure constraints, and you're going to have topology constraints. In some cases, those infrastructure constraints could be the fact that you don't have the necessary storage, or the type of storage that you are using isn't conducive of database mirroring. There's a good example. So obviously that comes off of the table. You don't have bandwidth to facilitate something like database mirroring or log shipping. So you really need to understand how your infrastructure plays into your solutions that you're planning, as opposed to trying to plan your solution and then looking at your infrastructure. And then lastly, you have topology constraints. If you have a single server machine running SharePoint, you are not getting any high availability no matter what you do, unless you add another machine, which basically means building a new farm because you've already done integrated or standalone database. So you have to understand how these different things constrain you to your high availability solution. You also have to understand that high availability is not just about the components that make up a farm or the components that make up a service within the farm, and it's not just about having content-based redundancy, 2 copies of a document, for example, or 3 copies of my data redundant copies of information that users create. It's also about capacity. Because one of the things you need to understand is if you exceed some specific capacity boundary, say you decide to throw 1 million site collections in a web application, all of the high availability in the world is not going to save SharePoint from tipping over. So I don't care how many front ends you have, how many database servers you have, how many application servers you have, you've effectively beat the boundary of the software and you brought it down anyway. Because there is a distinction between the software and the actual servers that the software runs on. You also need to understand how to protect before you protect it. I worked with a customer who had the best plan around how they were going to protect search, but they had no plan around how they were going to protect content. So at the end of the day, if something did fail, people would be able to search for stuff, but they wouldn't be able to get to those results because they didn't protect the content. So you have to understand, what am I using SharePoint for? How am I using SharePoint? Those are the things that you want to focus on first. And at the end of the day, while we have a wealth of capabilities and we have a broad range of features that SharePoint provides, business intelligence, social computing, we have a number of things. At the end of the day, SharePoint still remains content-centric. And what you need to understand about that is data loss is non-negotiable. You can live without search for any given period of time. An index can be recreated. You can recrawl. You can live without the user profile service for any given point in time. You can always import user profile properties again. These are things that you can rebuild. You can't rebuild your content, or your users can't rebuild their content. So a user can't be expected to, say, rebuild the last 5 years of data because it wasn't protected. So that's where data loss is non-negotiable comes in. Content is king when it comes to SharePoint, and that should be the core of what you protect. That's where you should invest all of your efforts and resources, and then look at some of the ancillary services that help people work with that content. You also want to apply service level objectives, so service level agreements, which is basically the 9s that we discussed a second ago. In conjunction with service level agreements, you need operational level agreements, or OLAs. And basically that's an agreement between you and the partner teams that keep SharePoint alive, such as Active Directory. I've seen a number of organizations who have a recovery time objective of 8 hours with SharePoint, whereas the infrastructure teams, such as Active Directory or Identity, they have a 16-hour recovery time objective. So even though you brought SharePoint back in terms of you spun up servers, nobody can authenticate to it anyway because Active Directory is down for another 8 hours. And then you as a SharePoint organization look like you failed. So it's important to understand, what are my dependencies, and align to those dependencies. You have your recovery point objectives and your recovery time objectives. So as you decrease your recovery point objective and you decrease your recovery time objective, so 0 and 0, so I want to be down no time and I want no data loss, obviously your solution is going to get more expensive, and then you're going to have to start thinking about moving away from the core stack that you've deployed on.
And those are tough conversations to have, but if you don't have them, it's kind of like, what I kind of give an example of having the sex talk with your kids. Okay, it's uncomfortable for everybody. No one really wants to be there. But if you don't have that conversation, you're going to have some problems later.
You also have to understand what's provided out of the box with SharePoint. I've seen a number of people that don't understand what SharePoint provides out of the box, or what SQL Server provides out of the box. So it's understanding, what do I already have? What have I already paid for? And then lastly, it's an ongoing process. It's not something that you set it and forget it and you move on. I'm going to move through this slide quickly so we can get to the core of the content, but I think it's important to discuss some of the fundamentals of high availability.
And what SharePoint talk would be a SharePoint talk without the circle.
Right. So from an analysis perspective, you need to, as you plan, you start with analysis, which is basically, what am I thinking about, or what do I need to protect? That's workload granularity. Coming back to that previous slide, content is king. That's where you determine what you need to protect, what drives your business. I've seen businesses who are driven by search. Search drives a business process or a manufacturing process. So obviously that's going to be crucial to the success of the business. So you identify those. You identify what threats you're trying to protect yourself against. Is this high availability for sake of protecting yourself against the failure of a component that comprises a SharePoint farm? Or is this high availability for another reason? Are you concerned about denial of service attacks? Are you concerned about malicious code or malicious intent? You have to think about some of those things as you perform your impact analysis. And then lastly, your objectives, your RTOs, your RPOs, your SLAs, and OLAs will tie into that. You move on from there to solution design, which is basically, can I meet my SLA? And that's where you start becoming realistic about what you can actually do from a nines perspective. And then you do your cost-benefit analysis. Could I theoretically do 5 nines if I do X, X, and X, but it's going to cost me $5 million versus doing 4 nines where I can incur acceptable downtime at significantly less cost. So that's the cost-benefit analysis. What's the difference between 5 minutes of downtime in a given year and 53 minutes of downtime within a given year? And then otherwise, you move on to your implementation phase, which is basically deployment, configuration. You move on to testing, where you validate your solution, ensure that you can meet it within SLA, and then lastly, maintenance, which is your annual review of the solution. The other thing you need to understand is you need to have the right people in place. So you need people that understand SharePoint, people that understand SQL Server, people that understand identity, people that understand core Windows Server fundamentals in order to achieve that. We've thought about that from a Microsoft-based perspective as we worked on our new certifications for SharePoint. So for those of you that have taken, has anybody taken a beta exam for SharePoint 2013? So some of you already have. I encourage you to do it. But one of the things that you'll learn is the beta exams are very SharePoint-centric. If you look at the new exam structure, so MCSE is coming back in terms of how we do SharePoint exams. It used to be, I think it was MCITP, so there was a Certified IT Professional, there was the TS-based certifications, and it was kind of a progression, but it was all SharePoint-centric, that progression. Now that's changed to where some of the prerequisites are based on core server fundamentals before you can achieve your SharePoint certification. The same is equally applicable to the developer side of SharePoint, to where you need to understand the core fundamentals of our new application model, which means experience with widely adopted web technologies, HTML, CSS3, JavaScript. And you'll see that those are prerequisites because we're taking that approach to SharePoint shouldn't be treated in isolation. So when you think about planning, you have unplanned downtime and you have planned downtime. If you think about unplanned downtime, the technologies that protect you from that, RAID, so having redundant arrays of disks. So we go back to our MCSE days, we think about RAID 10, RAID 0+1, RAID 5, and then of course there's proprietary systems such as RAID DP and RAID 6, but that's disk-based. Then you have backup and recovery, log shipping, database mirroring, failover clustering. Planned downtime is a different set of technologies. You're not going to use backup and restore for planned downtime, I hope. You're going to use rolling upgrades and patches. You're going to perform online operations, providing that the SQL Server is capable of doing so. You're going to leverage technologies such as database snapshots where you don't incur downtime. Downtime from an unplanned perspective is all about protecting yourself against failures, whereas planned downtime is all about maintaining the service as you perform routine maintenance operations. So now that we've kind of had a brief overview of what SharePoint looks like from a planning perspective, thinking about high availability and disaster recovery, we're going to move into some of the infrastructure aspects. The infrastructure aspects is, how do I load balance my services? I get that question all the time. I'm using Performance Point, and how do I ensure that Performance Point is highly available? One, you're not on a single box. That makes it pretty easy. If you have a topology that facilitates high availability, you already have capabilities in SharePoint that will keep that service up and running. For example, the application load balancer service. It is built, we built that service in order to simplify the installation of multi-server farms. So it's a basic round-robin based load balancer, and it directs requests to web service applications. So if you think about Performance Point services, you have two services or two servers on which it's provisioned. The application load balancer service through its endpoints ensures that Performance Point remains available even if only one machine is in the farm. Obviously, if you don't have one machine and there's only one endpoint, the service application itself won't remove that endpoint. You also have request management. How many of you have heard about request management or theories and rumors thereof about what it's supposed to do and what the intent of request management is? The good news is at 5 o'clock, right across the hall, there is a session on a 400-level session on everything you would ever want to know about request management. I highly recommend you go to it if you don't understand what it is and how you can use it. Basically, what it does is it prioritizes and routes incoming requests. So in SharePoint 2010, we introduced capabilities such as throttling, such as request throttling. That was something new that we did at the web application level. As we thought about that, we decided to evolve those capabilities and allow you to do some basic prioritization and routing of requests. So when you install SharePoint now and you use request management capabilities, every machine in the farm gets a health score. And then requests can be routed to those machines based on the score that that particular machine has. So we ensure that the healthiest machine in the farm always receives the request, and we're not directing requests to unhealthy machines. That's completely new to SharePoint. In the past, SharePoint didn't have an application-centric routing capability. It didn't know where to send a request. A request came in, and a load balancer sent it to whatever machine was responding. Some load balancers were more intelligent than others. But at the end of the day, the request went to a machine despite the characteristics of that machine. Request management now enables you to leverage those healthy machines and ensure a user's request gets processed by them.
And SharePoint is kind of raised up to the level of something like UAG or FIM. Anyone ever use those products? It's kind of the same kind of a deal where it's looking for the one that's healthy, and you set up different groups, and it's got a database that keeps all that information in there. So SharePoint is now implementing that type of a solution in that part of the technology, so it's really cool.
Another thing you can do with it is background services. You can prioritize user requests in favor of background services. And that's one of the things that people have always been asking for with SharePoint. They want to crawl data not within a maintenance window or within a specified time frame, because a lot of organizations perform crawl, say, in the evening or when they feel like their user base isn't actively using the environment. That way, responsiveness is dedicated to the users when they are using the environment. Unfortunately, from a search perspective, you want them to have results much quicker. So now what you can do is you can actually deprioritize a background service in favor of responding to a user. And that's an important aspect too, because now your users are benefiting, but you're also benefiting as IT. So it's establishing that balance again, enabling you to perform the operations you need to perform while not at the expense of the end user. And then lastly, you can also use it to block requests. So if you have known bad requests, you have denial of service attacks, perhaps there's an IP that you want to block, you can actively use request management to do that. You can also send a request to another server farm or to a specific machine based on the intent of that request. So you can discover the intent of a request, understand this is a query request or this is a search request, a user wants to execute a query, I'm going to send them over to this machine or I'm going to send them to this farm. So it enables you to do a number of things before SharePoint can actually process that request. And like I said, next door at 5, Spence is going to go very deep into what request management does and the different ways that you can use it. Beyond request management, what else do you have available to you? SharePoint installs on Windows Server. You have network load balancing available to you. Many people overlook network load balancing. They don't feel that it provides enough capability to support SharePoint. At Microsoft, we do a lot of network load balancing. Many of our largest farms, it's a number of front ends that are all load balanced using NLB. You combine that with request management, and you have a pretty rounded solution in terms of how you're going to enable application-centric load balancing. And it's been around forever. It's a pretty simple technology. It's all about balancing a request across 2 or more machines. You tie that into request management. So now you have native capability to load balance a request and native capability to route a request to a healthy machine, ensuring no request goes unprocessed, and you didn't incur any additional cost to do it. You also have failover clustering. Even if you are running a standard edition of a server, you can establish a 2-node cluster. You can have an active-passive cluster. You can have an active-active cluster. You still can have 2 nodes without stepping up to enterprise edition. So failover clustering is always available to you, and it's a perfect technology that complements SharePoint well. We did, in 2010, introduce support for database mirroring. So in 2007, really the only way you could effectively do database mirroring was you used client aliases. So you created a client alias which you faked SharePoint into thinking was a network name, and then one machine in your database mirroring partnership responded to the requests. The big challenge in 2007 was all databases had to be on the same node at every given point in time, and they had to fail over as a unit. If you think about that, it starts to sound a lot like a cluster. And I've always referred to database mirroring in 2007 as kind of a ghetto cluster. Because what you were doing was you were doing failover clustering, but you were just using database mirroring. So you were using a separate technology in order to do what one technology already did. In SharePoint 2010, we addressed that. So we revisited all of our connection strings and turned them into ADO.NET connection objects. which now enables us to specify the failover partner keyword within our connection string. We're continuing to build upon that, so database mirroring is still supported inside of SharePoint 2010 as well as SharePoint 2013. The important thing to understand is that database mirroring is being slowly deprecated, which of course means over time it's going to be obsolete. It's going to be obsolete in favor of always on inside of SQL Server 2012. It's a better technology for enabling database availability. Database mirroring, though, we should still talk about it. It's still something that people do in 2010. It's still something that people do in 2013. And it's something that people will do into the future until they move to 2012 and beyond. And it's basically a software-based solution that enables availability at the database level. Its granularity is deeper than that of failover clustering, and it's deeper than that of log shipping. So if you work your way down the hierarchy, you have failover clustering, which is per instance. You have log shipping, which is per transaction log, and then you have database mirroring, which is per transaction. So it enables a much deeper level of granularity than any other high availability technology available within the Microsoft stack. Not only does it do that, but it also enables you to have a warm copy or a hot copy of a database. So failover clustering, you still have one copy of your data. You have availability at the server level or at the instance level, but from a data perspective, you don't have data redundancy. Database mirroring enables you to have that data redundancy. It enables you to have a second database that you can always fail to in order to achieve high availability. And it also provides a new level of protection. So a good example is if you have two servers that participate in your database mirroring partnership, you now have availability at the server level because you can tolerate the failure of a server. Database mirroring enables you to tolerate the failure of a database as well as tolerate the failure of a transaction. And if you're using direct attached storage or you're using storage devices that are directly attached to the servers, you've also obtained storage level granularity. So you have granularity all the way down the stack from a database mirroring perspective, something that you don't have in failover clustering. You can also perform sequential upgrades. So you can fail over, you can patch, you can move back, you can patch. So you can perform rolling upgrades, that way you don't incur downtime as a result. Some of its characteristics, a lot of people are a little averse to using database mirroring. When database mirroring was officially supported in SQL Server 2005 SP1, there was a lot of speculation about its limitations, 10 databases, 5 databases. People said, well, SharePoint, when I install all of its service applications and I start adding content databases, I'm well into the 30s. Database mirroring can support well beyond just 10 databases, more than 15 databases, more than 20 databases. So that shouldn't be of concern. The thing you need to be concerned about is not the number of databases, but the throughput per second you can achieve with database mirroring. So when we look at applications inside of Microsoft, we don't look at SharePoint specifically when we think about database mirroring as a technology. We look at it in terms of online transaction processing, of which there are two types, light and heavy. From a light perspective, and just to put it into some context, SharePoint falls about in the middle, somewhere between light, but it's not heavy in terms of online transaction processing, if you just think about that generically in its sense. SharePoint falls somewhere in the middle. If you look at what happens here in this diagram, and you look at throughput per second, with mirroring off, so you can effectively think about that as a single server supporting SharePoint's databases, you're going to get about 241 in terms of throughput per second. Safety off, which is basically asynchronous mirroring. So mirroring comes in several operating modes. You have safety full, and you have safety off, or basically what you have is you have high safety, high availability, and then you have no safety. So it's asynchronous and synchronous, two of which are synchronous, one of which is asynchronous. The two synchronous come in different ways. There's manual failover versus automatic failover, which implies you have a witness server. But all that aside, if you look at with no mirroring, the throughput per second compared to asynchronous mirroring, there is no impact. The reason there is no impact is because asynchronous mirroring, your principal database is going to send transactions as fast as it can to the mirror database. It doesn't necessarily care whether or not that transaction arrives on the mirror database or not. We do not recommend asynchronous mirroring. We do support it in some cases, but we do not recommend it with SharePoint. The reason is there is no guarantee of transactional consistency with asynchronous mirroring. You always incur, or you could incur the loss of a transaction, which could be catastrophic from a SharePoint perspective. If you think about search, search is relatively stateless, beginning with SharePoint 2010, but we still do have a flat file index. We still do have a partition. That partition has a unique relationship to our search databases. If you don't have transactional consistency when you fail over, you might as well recrawl. That is why we always recommend synchronous mirroring. So despite the fact that we support asynchronous, I always recommend synchronous mirroring with SharePoint.
And this kind of goes back to the planning. If you're not testing this, it's not going to throw any errors because it's doing what it's supposed to. So if you don't check to see that it's working, you won't know.
And then what happens with safety full? Safety full is basically synchronous mirroring. So you have asynchronous where you incur no penalty in terms of throughput per second. You turn it on to synchronous mirroring, and as you can see, the penalty is marginal. It's negligible. It's hardly even noticeable. And it supports a broad range of bandwidth scenarios. And when I talked about your infrastructure planning, you have to understand your bandwidth because that's going to limit some of the technologies you can use. Database mirroring and even in synchronous mode can support lower levels of bandwidth. But the key point here is it's not about the number of databases that you can support with database mirroring. It's about the throughput per second that you can achieve with database mirroring because that's ultimately what's going to dictate how many databases you can support. And that's easily measurable through the database mirroring monitor within SQL Server itself. If you look at heavy OLTP, on the other hand, the story is completely different. So obviously in heavy OLTP, your throughput per second is going to go down anyway, regardless of whether or not you're mirroring. There is going to be a penalty when you use asynchronous mirroring, but again, it's going to be negligible, geez, I can't even talk today, compared to not having any mirroring at all. And then lastly, safety full, you're going to incur a substantial penalty in a heavy OLTP scenario. Heavy OLTP, if you have 500,000 users performing social-based actions within SharePoint, that's definitely going to be heavy OLTP. Status updates, @mentions, hashtags, doing a number of things, working with the newsfeed. That's going to be considered heavy OLTP. So at the end of the day, the key point to take away is SharePoint can support database mirroring well, regardless of the number of databases that you have, in synchronous mode, providing you can achieve throughput per second that enables you to get transactions from point A to point B easily measurable through the database mirroring monitor. And basically the things that you want to look at in the database mirroring monitor are two metrics, send queue and receive queue. You want those to be as small as possible. You want your send queue to be as small a number as possible and your receive queue as small a number as possible. And as long as you can keep those down and keep those manageable, then you should be able to do database mirroring. And you can continue to expand upon it and add databases and monitor that number to ensure that you can actually move a transaction from point A to point B. You also have to understand, well, what happens when I perform online operations, such as rebuilding an index? Depending on the operating mode that you choose to use with database mirroring, in some cases you should use non-peak times in order to do that. So as you look at this chart here, you have clustered indexes and non-clustered indexes. We're famous for clustered indexes based on GUIDs with SharePoint. So if you look at these numbers, with mirroring off, when you do an index rebuild on a non-clustered index, there's not that much of a performance penalty. It increases almost 100% as you perform a clustered index rebuild. Moving your way down, if you look at with safety full, which is synchronous mirroring, safety off obviously is asynchronous mirroring, and then the first one is mirroring off, which is no mirroring at all. If you look at safety on, synchronous mirroring, you're performing an online rebuild of a clustered index. It's 7.7 seconds for a typical SharePoint index. And if you think about 7.7 seconds, that's an eternity for an end user. It's a long time to wait for anything. You want it to be as responsive as possible. So you need to understand how your maintenance activities will play with the mode of mirroring that you choose to operate. Moving on to the mechanics of database mirroring. How does database mirroring work? Basically, it works in a number of different ways. Step one, database receives a request or a transaction submitted by a web server. It's written to the transaction log on the principal database. Simultaneously, it is written to the data log, so it goes to your MDF, and that same transaction is submitted to your mirror. Your mirror responds with an acknowledgement after it's been written, and then it gets hardened on the principal. That's full safety. Basically, there needs to be an acknowledgement. So the principal is not going to harden or commit that transaction in stone until it knows that it's received acknowledgement by the mirror, by its mirrored pair, that that transaction's actually arrived and has been successfully recorded. That's why we recommend synchronous mirroring. Right. Asynchronous mirroring doesn't really care what happens on the mirror. It sends its transactions, and if they never make it, they never make it. But again, you run the risk of failing over, and one of a couple of things are going to happen. Things just generally aren't going to work, or you're going to run the risk of creating orphans. And orphans can be created at any given level within SharePoint. It's not just limited to webs. So it's not an SP web scoped thing where you can have an orphan. It could be list scoped. It could be item scoped. It could be a document library. So orphans can happen at a number of different layers. What's important to understand about that is orphans are one of the biggest causes of failed upgrades as well, because you have to go in and clean them up. So from a best practices perspective, definitely recommend using database mirroring log compression, providing that you have the addition to do so. It reduces the send queue significantly, so when I talked about what you should measure, you should look at the send queue and receive queue, and you should keep those as small as possible. Using database mirroring log compression will reduce the size of your send queue. It's also going to accommodate data latency between your two sites, and then lastly, you're going to be able to support a broader range of network conditions by using compression. So even if you are in a case to where you don't necessarily have the bandwidth or throughput between your principal and your mirror, you can still use technologies such as database mirroring log compression in order to reduce the size and accommodate for latent links. Backup compression, again, the same thing. We looked at backup times within Microsoft, and we've reduced them by over 50% as a result. And we've seen over 85% compression when we've used database mirroring compression. If you're using backup compression, obviously, that's going to speed up log shipping because you're going to work with smaller transaction logs. Some of the other technologies that facilitate smaller transaction logs in SharePoint is shredded storage, and I talked about that a little bit on Monday. Basically, what we do is if you upload a PowerPoint presentation, we're going to separate that presentation into a number of chunks. So we don't have the concept of a monolithic stream inside of SharePoint's data stores anymore. It used to be we had a monolithic blob that represented the unstructured data or the PowerPoint presentation that an end user created. With shredded storage, what we do is we split that into multiple blobs. We do it differently based on the type of file that we see. So if you upload a PowerPoint presentation, we create a chunk at every slide. So if you have a 10-slide presentation, you're going to end up with 10 small blobs. And then when a user requests it, we rehydrate it. When a user submits a change, we only update the blob that corresponds to the change. So if the change was on slide 10, we only update blob 10. The reason that's important is because that means you're going to have smoother I/O patterns, but also a smaller transaction log. Because you're not creating a copy of the blob inclusive of the change, you're just simply updating an element of the original blob or of that big monolithic piece of data that a user uploaded to SharePoint.
And that really helps with your storage concerns because now SharePoint can deal with deltas, whereas before it couldn't.
So when you upgrade to SharePoint 2013, we will not shred any data by default. The only shredding that would occur is when that content is downloaded and uploaded again. At that point, we'll create a shred. So the simple aspect of attaching a database for upgrade won't shred the files, and it won't do anything with the versions that already exist within the database. What it will do is when a user downloads the file and submits it again, say they check it out and check it back in, at that point we'll shred it, and we'll establish a net new baseline through which we'll accommodate storage of that file. So you do have to upload and download the files again. Not necessarily upload and download, but perform any edit-based activity, such as a check-in, check-out. That'll definitely do it. Change the properties of a file. That'll help you do it as well. But that's kind of shredded storage in a nutshell and what it did and the intent of it. And the intent was to smooth out I/O patterns and reduce the size of transaction logs in order to facilitate a broader array of disaster recovery technologies. Some of the advantages of database mirroring, unlike failover clustering in the past, we've got a question way over here I'll take real quick. So the question is from a shredded storage perspective, is there any opportunity in the future that you may be able to set it by file type? To date, that's not something that we've looked at. It's not something that you can currently do in SharePoint 2013 as it's been released. Shredded storage at this point is a farm-level operation. In preview, it was kind of a site collection web application and farm-scoped operation, but we've increased that through RTM. But today, there is no way to set it by file type. You can disable and enable. Those are basically the options that you have available to you from a shredding perspective. And you can also specify the size of the chunk that you want created. So when we do chunk a file, we do it differently based on file type, but you also have the opportunity to specify the chunk size that you would like created or that you prefer. So in cases where you're using remote blob storage, perhaps smaller blobs facilitate that solution better. So you may want to reduce the default chunk size, which I believe is 2 gigs. If you're not using RBS or you've found that larger files facilitate better performance, you can always increase the chunk size. And you can also set the chunk size not only for put operations, but also for get operations. So the put operation, obviously, is when we shred it. The get operation is obviously when we rehydrate it and turn it into a stream that can be interpreted by the client. All of this is based on the COBOL protocol or file synchronization via SOAP over HTTP that we did inside of SharePoint 2010 to reduce latency between client and server. So coming back to mirroring, what are some of the advantages? It works with any kind of device, or from a storage perspective, it works with pretty much anything. There is no hardware compatibility list. There are no WCL tests in order to facilitate database mirroring. I can have a Dell server and an HP server. I can mirror between the two. I can have a server with 1 gig of RAM and one with 18 gigs of RAM, one with BIOS version 1 and one with BIOS version 8A. I can still mirror between the two. I can have one with Realtek network cards, and I can have one with something else, and I can still mirror between the two. I can mirror between Rick's laptop, and I can mirror between an enterprise server. It doesn't necessarily matter. You can mirror between anything. So you're not locked into a particular hardware set or storage set in order to mirror. There are no shared storage components. So virtually, you've eliminated all of those distance limitations that you've had in the past. Though, albeit, you have to be understanding and cognizant of how far you can actually stretch that out, because then you have to think about throughput, and you have to measure again send queue and receive queue. From a mirroring perspective, we looked at some of the throughput per second numbers. There basically is no impact to transactional throughput with database mirroring unless it's heavy OLTP and you're using full safety or synchronous mirroring. So it all depends on how active your environment is. There are self-healing capabilities in it. So if you're using Enterprise Edition of SQL Server, you have what we call torn page repair, to where we can replace information in a data page with information from the mirror. So if we find there's an issue on the principal, we can use a known good page from the mirror in order to fix that. So it's basic health capabilities, and some headers don't support it. The principal and mirror servers could also be a failover cluster. That's the most expensive form of mirroring. So you're mirroring and clustering. So you've added another layer of resiliency to your environment. But the good news is we have native support in SharePoint 2013. The bad news is, even though we added support in 2010, we evangelized it in 2007. For most organizations, it's still new and it's still untrusted. It's new to DBAs because DBAs have been familiar with failover clustering and clustering SQL servers for the longest amount of time, and they're a little averse, or there's some trepidation to using database mirroring, largely because they heard it doesn't scale well, or they just don't understand the technology enough to want to support it. We have to get past that and understand that it is a technology that works well with SharePoint. You also have some special considerations with agents and jobs that you don't have with failover clustering. Failover clustering is instance level. So when you fail over, all of those agents and jobs related to SharePoint are going to be there. With database mirroring, they're not. They have to be recreated on the mirror. So you set it up on the principal, you move to the mirror, and then you set up your agents and jobs there again. There are latency restrictions. In some cases, from a mirroring perspective, again, throughput per second, you have to be able to support a good throughput in order to do it. Otherwise, you're going to run up your send queue, or you're going to run up your receive queue. You want to keep those low. And then lastly, limited support. Why is there limited support? If we work down this list, instead of putting does support mirroring, I just basically put is it HA capable. As you can see as we work our way down, the staging database in 2010 for web analytics is not supported with database mirroring. That's good news because web analytics is gone in 2013 anyway, All of you probably know that by now. So we've removed Web Analytics from SharePoint 2013. So the good news is you don't got to worry about that one anymore. The rest of them remain yeses. If we work our way down, the user profile service application synchronization database is not supported. We are working on our capacities and boundaries documentation as well as some of our documentation for 2013 around what we will support from a mirroring perspective. You will see that evolve over time, but right now, just use this table. Use your 2010 table. But effectively, we have two databases that aren't supportive of database mirroring. We have one that doesn't really matter because the service application is gone, and then we have one more that we are revisiting even as we speak. So now let's talk about the successor to database mirroring, and I talked about that in the very beginning when I said database mirroring is on its way out. It's going away. We're moving beyond database mirroring and we're moving to always on. It's the successor to database mirroring introduced in Denali or SQL Server 2012. Always on is a perfect high availability and disaster recovery solution. So when we released Always On in Denali, which was the code name for SQL Server 2012, it also had a code name, and that code name was Hadron. We chose the name of Greek personalities in the Greek past to name some of our technologies with SQL Server. Hadron was one of them because it was perfect because it had the H-A-N-D-R in it. Hadron is, or Always On is, all about high availability and disaster recovery.
Trying to configure it, you should have thought like maybe Sisyphus.
Yep. Database. So from an always-on perspective, it provides both. Failover clustering is a great solution to provide one or the other, either high availability or disaster recovery. Database mirroring can facilitate either high availability or disaster recovery. But no one did too well until Always On. Always On increases application availability for mission-critical applications such as SharePoint, Exchange Server, Link Server, and a number of others. It does so by enabling both of those solutions. What it does is it takes the best of breed capabilities from our past high availability and disaster recovery technologies. So if you think about database mirroring, the way that we explained it, it becomes obvious that it's a one-to-one relationship. I can have one primary database or principal, and I can have one mirror database. If you think about log shipping, I can have one primary and multiple secondaries. So log shipping enables you to send a transaction log to multiple secondaries. Always On takes the best of database mirroring by providing granularity at the per transaction level, but it also takes those capabilities from log shipping, which enables you to mirror to multiple secondaries. So what it allows you to do is create what we call availability groups. You can take a bunch of databases and put them within an availability group, and then you can specify the type of mirroring that you want to use within that availability group, whether it is synchronous with automatic failover, synchronous with manual failover, or asynchronous with no automatic failover or no transactional consistency. So what you could effectively do is you could say, I have a high-volume application. I don't necessarily care from a search perspective about transactional consistency. I hope you do, but you could theoretically say, I don't care about transactional consistency. I just want operations to be performant, and I do want to know that I have the potential to have something to facilitate failover. You can take all of those search databases, you can create an availability group, you can put them in it, you can specify that that high availability group or that availability group uses asynchronous replication, is what we call it now, and then you specify a partner that it replicates to. You can then take all of your content databases. Again, content is king. It's the one thing you want to never fail. You can put them in a separate availability group and tie a policy to those. And that policy could be synchronous mirroring with automatic failover. So what you've achieved is performance enough to facilitate search with availability enough to facilitate loss of data or loss of one or more servers. It also combines the technologies of failover clustering. So when you install Always On, whether you're using failover cluster instances or availability groups, the first thing you have to do as a prerequisite is have a Windows Server failover cluster. The reason is because it responds to a network name or a VNN. And that's a benefit to SharePoint because now you can just point SharePoint at one network name and it'll fail over regardless of where your database is on. Always On will manage that for you. The key benefit is multiple secondaries in multiple sites using multiple modes of data replication. So you can have a number of availability groups. It's not a one-to-one relationship. It's one-to-many. You can take all of your content databases and replicate them to one point for a read-only experience and replicate those same to another point for a disaster recovery perspective. So you can do reporting in one site, knowing that you have disaster recovery in another, and production in yet another. So you have 3 copies of your data being used for 3 unique purposes. You can also back up your read-only databases with Always On. So you can have a reporting environment that also is used for backups. You can have a disaster recovery environment that you don't touch, and then you can have a production environment where the users actively collaborate. So you have the potential to have a number of different environments that facilitate a number of different purposes or enable a number of different types of scenarios. So you could replicate to a site that only needs read-only experience. Perhaps it's in the manufacturing industry. You have an assembly organization whose sole responsibility is to read standard operating procedures on a day-to-day basis, or provide them material data safety sheets, the MSDS sheets that you see hanging in a lot of places like hospitals. Perhaps the only thing they need to be able to do is read those. So instead of installing a SharePoint environment in that location, you can replicate content from your primary to that site and yet replicate that same content somewhere else for a completely different purpose. There's also the concept of failover cluster instances, which expands upon failover clustering, and it enables new capabilities such as flexible failover policies, which basically is the numeric scale that you can dictate when you should fail over in the event that an event occurs. So false positives don't happen anymore with failover cluster instances because you can specify what types of events should actually trigger a failover and how should that failover occur and where should it occur at. Lastly, Always On also supports multi-subnet failover clusters. One of the challenges in the past was doing anything multi-subnet with MSCS, or the Microsoft Cluster Service. Really the only way that you could achieve multi-subnet failover is you consulted a vendor that provided some code that wrote on top of MSCS that enabled you to span subnets. The other thing that you had to do is you had to build the infrastructure in order to support that. Always On, out of the box, supports multi-subnet failovers, or multi-subnet failover support, I should say. In order to do so, you need to modify connection strings. Obviously, in SharePoint 2013, our databases are black boxes, and so are our connection strings. We don't like people touching them, looking at them, with the exception of the usage database. So what we've done is we've introduced new PowerShell commandlets to enable you to support a multi-subnet failover cluster. So if you have a failover cluster that spans subnets, we have the multi-subnet failover parameter that you can use at the database level inside of SharePoint 2013. So we've actively built in support for that, and that snippet is what can be used to set your databases in order to support multi-subnet failover. If you are spanning subnets, it is crucial that you run that command on each and every database because SharePoint will not respond well without it.
It has to be done on each and every single one. And a couple of other things. The always-on requirements, 64-bit edition of SQL Server or the 64-bit edition of SQL Server 2008 R2 SP1. This is, it would seem to be intuitive. I found out, however, that if you do not have this, you will get an error message when you're trying to enable Always On. For those of you who have moved to the cloud, you might want to ensure that your cloud provider really does provide you 64-bit edition of SQL Server on top of 64-bit edition Windows Server 2012 or 2008, because if not, you will get this nice little thing that shows up that, hey, you're really running WoW. So when I tried to do a demo today for you guys, guess what I got? Yeah. So my cloud provider actually did it says 64-bit edition, but it was not. It was 32-bit edition SQL running on 64-bit edition server. So watch out for that. Okay, so make sure that that's straight. After that, make sure, hopefully, some of you are doing this. How many of you are running SharePoint on a domain controller? I know a couple of you are. Okay, no worky. Okay? If your SQL Server is sitting on that same server and it's a domain controller, it's not going to work. Okay? Every node must have the WSFC enabled. So the first step that you go to is enable the failover clustering on each and every one of the servers.
And that requirement is not limited to just failover cluster instances with always on, but it also applies to availability groups as well.
Correct.
So availability groups, you look at them and you say, well, this is just database mirroring, a combination of database mirroring and log shipping. You also need failover clustering. The reason you need failover clustering is because it responds to a network name, and that network name is established by failover clustering. So we don't leverage all of the capabilities of Windows Server failover clustering, but we do leverage that network name in order to provide the service to SharePoint.
And you're going to go to that service anyway. When you fail over those servers, if that service isn't there, then guess what? You don't get the UI. That's why you have to have it there. Also, you'll want to install these hot fixes. If you are running... Oh, it kind of ran off of the thing, didn't it? There is another hot fix there. I can't get rid of that one. Lock taskbar. Go away. There it is. Okay, so those two on the bottom, if you're running Windows 2000 Server 8 or 2008 R2, there's two separate hot fixes that you'll want to do for that one.
So moving on to the advantages of always on. Obviously, it has all of the advantages of database mirroring. It works with any given piece of hardware. There are no unique hardware requirements. There are no shared storage requirements if you're using always-on availability groups. So now you've eliminated the need for hardware compatibility lists. You've eliminated the need to run a WCL test against hardware to make sure it's compatible to run a failover cluster because you don't need it. You've also eliminated all those shared storage components that limit the distance that you can actually span. You can support failover across subnets. Just like database mirroring, there is very limited impact to transactional throughput depending on what you choose to implement, and it is a straightforward migration. Migration from database mirroring to always on is a fairly easy transition. Yeah. From a disadvantages perspective, there basically are none if you think about always on. And I'm a SharePoint person, and I'm not trying to sell you SQL Server. I'm just telling you that I've used it myself. I've set it up myself. How many of you were at the 2011 SharePoint conference in Anaheim? How many of you saw full farm failover? And all of you probably know that was based on always on. It wasn't just based on always on, it was based on a pre-release version of SQL Server. It was still Denali. So we were using early pre-release code, and we took an entire 14 terabyte SharePoint environment that had over 10,000 concurrent users hitting it. We failed it over in less than 40 seconds and had responsiveness back from SharePoint. So it is a technology that actually works. There was a question back here just a second ago.
Yeah, our SharePoint 27, where the database is by default grows rapidly because it's in full recovery mode. So the idea is just
simple. And you fired him?
No, yeah. Yeah, that.
No, it has to be in full recovery for always on.
Yeah, exactly. That's the thing. So when you start always on, you have to put them back into
Yeah, so obviously, based on database mirroring, you're going to require full recovery. You should always just leave the default recovery model that SharePoint uses or implements anyway. The concern that we always see in terms of our recovery models is people say, well, how come everything's always by default in full recovery? The thing's just growing at an exponential rate, and I can't control it. In 2013, shredded storage, again, addresses that issue. So you shouldn't see that exponential growth. And if you're at my session on Monday, I showed you how I could work with a 7.8 meg or an 8 meg PowerPoint presentation, induce change, and the only write cost associated with that change could be measured in kilobytes or even bytes. So from a growth perspective, and even if you were at the keynote and you saw the scale that showed the growth of a 2010 content database as relative to the growth of a 2013 database, they were on completely different trajectories just due to some of the things that we've done. So you shouldn't have to worry about that anymore. Don't ever mess with the recovery models that we provide out of the box. And again, that's why we always say just treat our databases like a black box. Don't look at our schema. It's not that we have anything to hide, but people tend to look at it. They want to do things, and they say, well, an index would look good, a trigger would look good. If I added a job here, things
And you
would be
do
that
know
much
you
faster.
go unsupported if you do touch those, right?
The other thing that you find out too is you apply a cumulative update, and our updates, whether it's a cumulative update, a public update, a service pack, a security patch, they are all very dependent on our schema being unmodified, because we look at that extensively as through the upgrade process. So you do have some latency restrictions because you are mirroring if you're using availability groups, and from a limited support perspective, we have not yet published what the limits will be for always on in SharePoint 2013 databases. Hopefully the answer is we support all databases across all ranges of support. So moving into topologies, from an architectural perspective, as I talked about in the very beginning, SharePoint is distributed across 3 basic tiers. The web tier, responsible for responding to HTTP requests as submitted by users. Web servers in a SharePoint farm should only ever be web servers in a SharePoint farm. Granted, you can install query services on those machines. You can turn them into query servers as well, at the expense of responding to requests. You can turn them into a number of different things. I've seen customers who have turned web front ends into file servers. So they decided to put file shares on the front ends because, well, I already had those servers available and I didn't want to buy separate servers for file shares. I've seen a number of different activities. A web server should be a web server like it is anywhere else. I don't care if it's Facebook, Twitter, anywhere. It's a web server, and that should be its sole purpose in life, is responding to users. It's going to do a number of different things for you. One, you're not going to be running unnecessary services, so you're not going to be constraining any compute resources. You're not going to be using the same amount of memory. You're going to make more efficient use of those resources on that machine, and you are going to reduce the troubleshooting plane significantly because you are not going to have as many moving parts on those particular machines. You then have your application servers, which facilitate the many services that SharePoint provides, and lastly, the database servers. That's the 3 tiers. Those 3 tiers align to our physical architecture. On the web front ends, there's a number of things that you could have there potentially: query processing, distributed caching, request routing and prioritization, which you'll hear about at 5 o'clock. The application servers, same thing: query processing, request routing and prioritization, distributed caching, and then database hosting on the database side. I'm not going to spend a lot of time on these diagrams. Logically, it's how it aligns. We're not going to talk about how SharePoint aligns logically. Most of you probably already know our tiered hierarchy, starting with farm and moving your way down through site collection, site, and then you move your way into lists and items. So we're not going to go there. From a topology planning perspective, the funny thing about SharePoint is if you look at our topology guidance on TechNet, or you look at most SharePoint topologies, it aligns very well with what you see across the top. Who in here can tell me what you see across the top?
If you talk to me, do not. It's not fair.
Anybody? There you go. SharePoint topologies align well to the Fibonacci sequence. You start with a single server installation that your developers are using. You move on to a 2-box, which is a web front end, and a SQL server, which scales into a 3-machine, and then you get into your cookie-cutter 5-machine farm, 2 front ends, application server, 2 database servers.
You know the boy ain't right when he figured that out.
So, if you look at the TechNet guidance, you'll find that there's a number of different ways that we describe farms. Small farms for development and evaluation, small farms for pilot. You're going to find that it aligns well, or exactly to these numbers. So, from a simple farm perspective, your minimum scale-out topology, if you want to do it in a seamless fashion, is basically to have 3 machines initially, and then begin to add from there. Why? If you look at a 3-machine topology, it's not highly available. It's generally going to be a web server, application server, and a database server. But from a scalability perspective, once you have that foundation laid, it becomes very easy to scale, because now you're just creating widgets. You're plugging in components. It's extremely easy to add a web server to a SharePoint farm. Even though we added the passphrase aspect because that's how easy it was. It was so easy to add machines to a farm in 2007, we had to add a passphrase in 2010 to prevent people from just errantly adding machines to farms. But it's all about adding components from that point. You have 3 machines. You have a web server, application server, database server. Now you're just plugging in components as your infrastructure grows or as your high availability needs change. So I can plug in a new web server seamlessly. I can plug in a new database server. I can plug in a new application server. And I can continue to scale along the lines of that sequence fairly easily, providing that I start with a scale-out topology in mind. So even if your original topology isn't conducive of high availability, it's easy to get there because it's just plugging in components or making widgets. Unless you're using integrated database, and then it's a lot harder because you're rebuilding. On the web server end, it's pretty easy. It's the web server IIS role. That's what we install in addition to the application server role when you lay down our binaries. Easiest way to protect that, network load balancing. It's there, and you've already paid for it. Why have you already paid for it? Because you've already licensed Windows Server. I hope you've already licensed Windows Server, which means you have network load balancing available to you. It's pretty simple. You're using what we've already given you or what we've already paid for. It's maximizing your investment. Where it gets expensive is in search. Everybody wants highly available search. I've never come across anybody that doesn't want highly available search. This is where you're going to incur the most of your cost. How do you balance that? Use the technologies we give you out of the box, such as on the web front ends or the back ends, and then invest your efforts in search if you feel so compelled to do so. You're going to need a number of machines in order to have highly available search. This is the minimum scale-out topology for highly available search. It encompasses 4 machines. You could virtualize, but that's still going to have to span 2 machines. You're not going to put all 4 on one machine because then your virtualization server becomes your single point of failure. So in a best-case scenario, in order to do it from a virtualized perspective, you're at least going to need 2 hosts. And you're going to drop 2 machines on each host, and you're going to distribute that way. But basically what you're going to do is you're going to duplicate your components across 1 or more machines, or 2 or more machines. So in this case, server 1 and server 3, if it was a virtualized scenario, server 1 and server 3 would live on 2 separate virtualization servers. You're going to be duplicative in the components that you install on those. So analytics processing, the admin component, the crawl component, a lot of the new components based on our unification of the fast search engine. And then what you're going to do on the other 2 servers is you're going to be duplicative about some of the query components and some of the index components. Those 2 machines will also facilitate partitioning of your search index. So now that you've distributed components and you've been duplicative about how those components are distributed across machines, you need to think about the actual index itself. And what you do from that is you partition that index across 2 or more machines. So now you've achieved multiple levels of redundancy with search. This example is a minimal scale-out search topology. So again, from a search perspective, you incur cost. So it's best to look at where can I do things relatively inexpensively because I've already licensed or paid for the technologies, and then I'll invest the latter of my budget or the remainder of my budget in order to support something like search. Database server topologies are pretty easy. As long as you have 2 of them and you have SQL Server, you can mirror, you can failover cluster. It's pretty easy. You can also use always on, providing that you have the addition of SQL Server that supports it. From a client perspective, when I talked about educating your end users, there is no excuse anymore to not use versioning. I've had this conversation with customers in the past, and they say, I don't want to use versioning because of the storage cost that I incur. I spend a lot of money on SharePoint storage. The storage that my databases reside on is the most expensive storage in my organization, and the last thing I want to do is waste space. The reason they were wasting space is because, again, a version of a 10 meg file was a 10 meg file inclusive of its change, a copy of the file inclusive of its change. The next subsequent version, a copy of the file inclusive of its change. So 5 versions of a 10 meg file could effectively be 60 megabytes or more, unless you're removing data, and then it could potentially be smaller. But you're using an inordinate amount of storage to facilitate versioning, so they didn't want their users to use it. With Shredded Store, you should have no concern about using versioning in SharePoint 2013 because we maximize the utilization of storage. We make more efficiency in terms of how storage is used and the cost and size of a write. So now your users should be welcome to use versioning as part of the SharePoint solution. But at the same time, what it also provides is self-service recovery at the item level, which means you don't need to buy yet another technology to facilitate self-service recovery. It takes some education. You need to help your users adapt to using versioning. You need to enforce it. You can write feature receivers that can enforce the use of versioning across site collections or sites. But again, it's something that you shouldn't be shy about. Our recycle bin is going relatively unchanged. I always teach users how to use it. Why do I teach them about versioning? Why do I teach them about the recycle bin? For one specific purpose. because I hate getting up in the middle of the night, going back 7 months worth of backups to retrieve a document that takes me 3 weeks to do, and you start to calculate the cost, the frustration that comes along with it, simply because somebody deleted a document and emptied the recycle bin, or didn't empty the recycle bin and they realized it was there. And I went through all the expense of not being able to find it on disk, making the unfortunate and miserable trip to Iron Mountain. Nothing against Iron Mountain, but I just don't like getting up at 3 o'clock in the morning and getting in the car and driving to some facility so I can try to retrieve a tape. And if any of you have ever done that, it is inordinately hard, and it's a good thing that it is because they have a lot of security measures in place, but then you realize you forgot 90% of the stuff that you need at home and you make 6 trips just to get a file, only to find out, and this has actually happened here at Microsoft, that that file is a recipe that that individual lost. Yes, that...
You said you wouldn't tell anybody.
That has actually happened at Microsoft. So usually, the practice isn't, well, let's see what we restored to see what this user needed so badly. But this just happened to be one of those circumstances where that file got cracked open, and that file was a recipe that was deleted. That probably, when you figured out the cost, ended up somewhere between $11,000 and $13,000 when you figured in the human costs as well as the costs of restoring to get that back. So in summary, because we only have 4 minutes left, high availability is something that never stops. It's something that should be ongoing, that you should practice, that you should evolve over time. As technology evolves, so should your high availability solution. And it is not just about components and content, it's also about capacity. If you exceed the boundaries that SharePoint provides, your highly available solution won't matter. It doesn't matter the number of front ends or the number of database servers, because the software itself is not going to respond, which means the servers themselves aren't going to help you. So if you want to get started learning more about SharePoint, you can use these links. You'll have access to the slides as well as the video recordings. They take about 48 hours to process. You should see Monday's videos becoming available today. You should see Tuesday's videos becoming available on Thursday, and so on. You'll have access to all of the videos. One of the things I can tell you, see the misfortunate or the unfortunate people that left before the section ended are going to miss this. Download the videos as soon as you see them.
Sure.
So as many of you remember, we had a SPC site for 2009. It is not perpetual. It will not live forever. So if there's anything you want, I'm just saying get it right away as soon as it becomes available.
Yep.
For all of you that weren't there on Monday that haven't discovered it yet, RTM trial of SharePoint 2013 is available, even if you are not a TechNet or MSDN subscriber. You can download it and start using it today. And then lastly, training down the hall. If you haven't taken a beta exam, I recommend taking a beta exam,
it's closed.
checking that out.
It is closed.
Oh,
no more beta exam for you.
Never mind. Lastly, there's also a reviewer's guide that's been refreshed for RTM. How many people saw the preview reviewer's guide? A couple of you have. So search for SharePoint 2010 IT Professional Reviewer's Guide. There is an RTM version that has some changes based on some changes that we've made from a product perspective that you may have yet not discovered, such as shredded storage. And lastly, check out SharePoint on TechNet. The other thing that I'm going to show you, and I'm going to get to that question right back there, is how many of you have seen the new PowerShell command builder? Awesome. So we obviously have a new PowerShell command builder for SharePoint. It's HTML5 based. It's touch enabled. It'll work on your touch devices. You cannot double click on a verb or a noun. The reason you can't double click is because all touch devices interpret a double click as zoom. I learned that the hard way. So what you can do is if you have a touch device, you single click and it brings up a nice little send menu and you can send the commands to the screen. Over time, you will start to see other products build into that builder, such as Exchange and such as Link, as we take more of a dependency on PowerShell.
Oh, you know what? I forgot to mention. If you are going to use Always On, the PowerShell, you will need to import all of the SQL modules for that. I forgot about that.
And I am going to get to this question right over here now.
So if I have RPS in my environment, how do I get to use the DR
So from an RBS perspective, one of the mistakes that I see people make is a lot of people have moved to RBS under the assumption that their databases are going to be smaller and that the only thing that they need to replicate are these small databases. Unfortunately, you still have the content that you have to deal with. That content isn't out of sight, out of mind. It still needs to be kept in sync with the actual metadata itself, or the structured data that remains in your database. The best methodologies for replicating that content from point A to point B is there's a number of different ways that you can use it. My favorite, distributed file system. So DFS replication is what I like to use. I like to use DFSR in Windows Server 2008 R2 or Windows Server 2012 to replicate. That's an effective way to do it, and it's a cost-efficient way to replicate your offloaded blobs. So all of your documents now sit on some file server somewhere, or some content addressable server. You can use distributed file system replication, or DFSR, in order to do that. Otherwise, your only other option would be looking at a vendor that provides kind of some of those capabilities. But if you want to do it within the Microsoft stack at the most reasonable cost, then you could use DFSR, and I'd recommend checking that out. Another question right here? Right. Mm-hmm. So in SharePoint 2013, we are actively working on that guidance. When I left Redmond, I can't even remember how many days ago at this point with the conference, but when I left, let's just say about a week ago to come out here to Vegas, our team that's responsible for our documentation for database mirroring, as well as always on availability groups and failover cluster instances, was working on the guidance. I haven't seen it myself, otherwise I'd answer the question. I can give you this recommendation. The guy who's responsible for it is here, and he is at the IT Pro booth down in the expo hall. His name's Dan. And if you ask Dan, he's the guy that's writing the documentation, so he's probably got a better bead on what we know. Also, please submit an evaluation, and I will read everybody's comments. I always do. I always like to see what the comments are. It helps me improve. It helps me plan for next time. What doesn't help me is if the lighting was too bright or the room was too cold. I can't change that, and it's unfortunate. And I know in some of the rooms the audio was just abysmal. In this room it seems like it was a little bit better. Right. Thanks.
Yep, thank you.
But again, you know, it's something that I can't change, but I will definitely take any feedback. Again, if you want to connect with me, visit me at www.wbear.net. Don't be shy. If you add me on LinkedIn, I will accept. If you send me an email, I will actually respond. So if you have a question about SharePoint, I will definitely respond to it. So don't be shy.